I think I did. Yes, we're good. We'll see how it works. Okay, so, okay, wait, let me answer your question. So is this a function? No. Okay. Because x value repeats. Again, if you wanted to be specific with a -2, that's the one repeating. Okay, so ask your question again. Can the y's repeat? Sure can. So if I look at this first example here, look at the y's. See how there's 2 5s? Doesn't matter. Okay. Correct. It's almost like when you're looking for a function, the y's are irrelevant. Don't even look at the y's. Okay, good question. Just look at the x's. Yep. Okay, the other way to tell, so that's if it's a list of points. Okay, the other way to tell is when you look at a graph. So all those 5 functions we gave you at the beginning, okay, I'm calling them functions because they all pass something. What do they all pass to test if it's a function? Good, the vertical line test. Meaning you draw vertical lines on the graph and each vertical line can only touch the function once. So if I did it up here with all these that are claiming to be functions, okay, I would only touch once. If I look down here, so this first example, I'm going to draw a bunch of vertical lines. They go up and down. It's only touching the function, not the axis, so only the red part. So is that first one a function? Yes. Okay. And then you could say because it passes the vertical line test. Is there such a thing as a horizontal line test that we've talked about this year? Okay, no, there is such a thing, but we've never mentioned it at all. And the reason I bring this up is because last year's exam or the exam before, we put it on a quarterly or something, a midterm. We gave you guys a picture and it says, is this a function? And then it was yes, because it passed the vertical line test, or there was a choice that said yes, because it passes the horizontal line test. We have never talked about the horizontal line test. Okay, so that's never going to be an answer. That's not in our curriculum. Okay, only vertical lines. Okay. All right, this second one here, is this an example of a function? Why not? It doesn't pass it. Pass what? Vertical line test. Right there, I draw a vertical line. It touches twice. Okay, touches what we're claiming, what we're testing to be a function twice. And we can't do that. Okay, this third one, is it a function? Yes. Specifically, this third one has a name. What is it? That's a quadratic function. Like the whole Zoom. Bless you. Oh, I thought you were telling me to open and close that. No. Okay. All right, let me give you one more example. Okay. What if, I want you guys to draw this in. Okay, and specifically, I'm making that kind of a closed dot like that. I'm going to draw the rest of it like that. Okay. So my first question, this is a piecewise function, okay, because it's pieces of different functions on the same graph, okay? So here's a piece perhaps of a linear, here's a piece of a quadratic. Okay. So now my question is this picture, the whole graph, a function? Okay. Not each piece, is the whole thing a function? No. Yes. Okay, why? Yeah, so if I draw it, okay, I'm passing. All of a sudden, right here, they were supposed to line up if it was nice. It hits 2 points, okay, but you hit it right very correctly. One of the points is what? Closed and open. Closed, and one is open. What's the only one that counts as part of it? Closed. Closed, okay, so counts. An open one does not count. Okay. The other thing, be careful, we're not looking at its pieces. So this has been shown up on an exam before, and people will be like, oh yes, one piece is linear, so that's a function, one piece is quadratic, and that's a function. I'm looking at the whole graph as one thing. So just because you see something, yes, we talked about 5 types of functions. We talked about linear, exponential, square root, quadratic, absolute value. It's not the only functions that exist in the world. Okay, there's lots of functions that don't even have names. For example, I could draw something that looks like this, or really this first one here. Okay, do we have a specific name for something that does that? No, doesn't mean it's not a function. It still passes the vertical line test. It's just not one we looked at in depth. Okay, so same thing with this. We don't have a specific name for it. It's just two pieces, but the whole thing together is one function. If this point was closed, would it be a function?
Yeah.
No.
Well, if we flip-flopped and this became open, then yes. But if they were both closed, would it be a function? No. What if they were both open? Yes, because it technically is not hitting anything there. Okay? What? Even if it's dashed, it doesn't count as a point. Yeah, so it would just be like drawing a vertical line in the air. Like, you can hit nothing. That's fine. Okay?
Think of like your square root function.
Right.
Right on the top of our page, we have a square root function. It doesn't fit everywhere, right? There's part of the graph that's the same anything.
And it's still a function.
Yeah, it's still a function.
Okay. Good questions. All right, so then there's a lot of important vocabulary that goes around functions. Okay. Domain is our x values. And so if we're looking at a function, x values go which direction? On a graph. Left and right. Okay. So when we're talking about domain, we're talking about going left and right. And then range goes what direction? Up and down. Good. Okay. If you want to give me a second and write that down. So domains, left and right. Okay. Range goes up and down. You would start furthest left if you were listing domain, and then end where it goes furthest to the right. Range, I probably should have wrote that backwards. You would start at the bottom, and then how far it goes up. Okay. All right, let's draw a little graph in here. Okay. I'm just going to draw a random one if you want to draw that in. Okay, where are the x-intercepts? Or which one's the x-axis?
How many are there?
So on this graph, there's 3. 1, 2, and 3. So x-intercepts where the graph crosses the x-axis. Our x-axis, again, is the one that goes left to right.
What? Oh, sorry. X-intercepts have zeros and what else? Roots and one more. Starts with an S. Solution.
So factors are where you take the zeros and change the sign. Factors. No. So this would pass the vertical line test. So this is a function here. Yep. Okay, then the y-intercept. How many y-intercepts are there? 1 here. And what's another name for the y-intercept in all our functions? What? Yeah. SV. Yes. SV. Yeah. Okay. Quadratic functions, that's important. Like we are doing a whole day on quadratics, but for the applications, like where was the ball thrown from to start? Look on the y-axis. How high was the ball up in the air? That would be look on the y-axis. If it's linear and it's at like I initially make $100 and then I make $10 every hour after that, your starting value is 100, so that's what the y-intercept. It's the one that doesn't have the variable attached to it. All right, increasing intervals. So if I'm looking on a graph, it's where the x values have a positive slope. What direction does a positive slope look like? It's going up from what direction to what direction when I read it how? Alexa, yeah, from left to right, yes. Okay, so positive slopes go that direction. From left to right, it's going up. So then a decreasing interval is where it has a negative slope, and where is that occurring? And what does the slope look like? What's a negative slope look like? It's going down from left to right, so it's the opposite of positive. Okay. And then a constant interval is where it has a zero slope. So what does that look like? It says it right there. Straight which way? Because all lines are straight.
Left to right.
Left to right. Okay. All lines are straight. Be careful when you give the definition. Okay. All right, the last thing is evaluating functions. These questions are very popular and they should be super easy. Okay, you're given a function. Okay, you can type the function into the calculator. Okay, why don't you all, if you don't already have one, why don't you guys go grab a calculator real fast? It doesn't matter what number you grab. Guys, grab a calculator. Okay, so if we wanted to evaluate the function here, okay, we're evaluating absolute x minus 2 plus 3. First of all, it's a function. What button do we always press to type functions into the calculator? Y equals. Okay, if something's there, clear it out. How do we get the absolute value bars?
Second. No. Second window. Yeah.
No, not second window.
Alpha
It's
window.
written at the top. That's why we highlighted it.
Yeah.
Okay, alpha window. Which one? The very first one, ABS, and the bars are there. Okay, when in doubt, like you're there on the test and you're like, oh, second window, right? And you try it, it's not where you want to be. Okay, so just try something else. All right, so alpha window.
You guys can't ask us to calculate, or you can, but we can't answer. So if you can't remember how to get to absolute value, we can't help you.
Oh, can you not tell that? Oh, interesting. Okay, so x minus 2, put in with the absolute value. And then the plus 3 is after it. So how do I get out of it? Arrow to the right. So make sure it looks exactly how you want it to look. So there's my function now in the calculator. Now, how am I going to evaluate? Whatever we're trying to evaluate.
Go to the table.
I'm going to go to the table. So how do we get to the table? No.
Second graph.
Second graph. Okay, again, read your calculators. There's a lot of words there to help you. Like tables written in blue. Okay, so second graph. And what value are we going to? 3 in the X column or the Y column? The X column. Okay, so evaluate the function when X is 3. So what is our answer? 4. It's what the Y is. Okay, so the number they give you in parentheses is the X value. So that's X. So then we could say f of 3 is equal to 4. Okay? What?
How do you change it?
Okay, so question. So what if I said evaluate, I'm just going to throw this one up. Evaluate f of 0.5. Okay, so that's not going to stay here. Or 0.5 doesn't show. Second window. So to make it what you want, second and then window. Okay, so if we went to second window, you could then type it right in table start. That's the only one you change. If I made it 0.5, then went back to my table, what would be the answer? 4.5.
How do you go back to change?
Okay, good question. How do we go back and change it to regular so it's not messed up the rest of the test?
Just press it in like
0. I would always make it back to 0. So you would do second window, and I'd go back to 0. Okay, that also works if you're trying to evaluate a super large number like 100. Okay, yes, you could scroll all the way down to 100, but you could save yourself a little bit of time if you did second window and just typed in 100. And then again, if you went back to 0, it'd go back to normal. Okay. Good. All right, so let's look at some examples here. So we have a graph. So first question, is this a function? This graph here. Okay, yes, why? I gotta be a little more specific than that.
it passes the vertical line.
Okay, I like that. So yes, I think someone in the back said it. Because it passes the vertical. I'm out of room with this awkward thing here. Line test. Okay, again, how do I know that? If I drew vertical lines, okay, what does passing the vertical line test mean? What just happened? Each vertical line only touched the graph once. Yep. Okay. Let me erase those to make the rest of our life easier. Okay, domain. Domain we said was which values? X values. So we read domains which direction? Left to right. Okay, what is the furthest left this graph goes? What's the furthest left this graph goes? Where does it start when I look at it left to right? What? Okay, that's up and down. I'm looking x-axis, domain. 0. Okay, and it ends at what? 4. Don't go until the end of the like graph you see. Okay, the grid. Actually do it. So from 0 to 4. Okay, and if we wanted to put a label on it, it's 0 to 4 what? Minutes. So be very careful. Like this, we can't stress enough. If it says include units, this is a point, and this is a giveaway point, but also very common where people lose that. Okay, so at 0 to 4, what was the x-axis measuring? Minutes. Okay. All right, the range. Range is which values? Y's, up and down. What's the lowest the graph goes? The function. 60. 60 through what? 110. Good. So just because, yes, it gets up to 100 and then dips, you're just looking at the whole picture. Okay, lowest to highest. So 60 to 110, what? Beats per minute. You're just reading the scale, the Y side. Okay. All right, y-intercept. Which one's our y-intercept? Okay, the y-axis, that's up and down. So it's right there. So our y-intercept is 60. Okay. All right, constant intervals. Okay, constant interval. What does the graph look like, first of all? What does the graph of a constant look like?
Left,
Okay. Horizontal. Yep. So 2 to 3. Yep. Minute. It's always, you always use X values there. Okay, where is it increasing? Where is it? I'm sorry.
3 to 4.
3 to 4. Okay, there's one.
Any other place where this is going up?
0 to 1.
Okay, so could I say 0 to 4? Does it go up the entire time?
No.
No, so you got to make sure you break it. It did it twice. So it did it from 3 to 4 minutes, and then I can put a comma, or you could write the word and then it also does it from 0 to 1. Okay, but make sure you're not saying the whole. Okay. Think of a ball, like when you throw it up in the air. It's still going up the whole time. No, technically not. It'll say like include units if it wants to. You could write y equals 60, that would be fine. Yeah. Okay, decreasing, where's it decreasing? 1 to 2. Yep, and 1 to 2 minutes, good. Okay, now evaluating. Did they actually give us the function to type into the calculator? No, so there's nothing to type in the calculator. We're going to look at the graph. Okay, but it's the same idea. The number in parentheses is which variable? That's the x. Okay. Yep. Okay, think about how you write functions all year long. F of x, g of x, h of x, a of x. Okay, it's x in the parentheses. Okay, so we're going to go to which axes to look at too? The x-axis. Okay, is that across the bottom or up the side? Across the bottom. So I'm going to go to where x is 2, and then how do I find the answer? How many did it take? So where are we at? 80. So f of 2 is 80. Okay, so then what would evaluate f of 0 be? Yeah, so 0 is the x. We're going to go up to our graph, so it's 60. Okay. You want to do the next one? Okay. I don't know how much time we actually have left. I might have to stop the session. I actually think that might be better. Yeah, okay. We'll just do it again.